Okay, let me write this down and then I'll maximize this. It's 2.5. Infinite limits. Question number 1. There. Okay. All right, so what we need to look for is the asymptotes. So the first thing you got to do is factor, which will see that this is a difference of squares. Right? So the difference of squares starts on the bottom for x plus 4 into x plus 4 times x minus 4. Nothing crazy. But we should see that plug in 4 and negative 4 will cause division by 0, which is where the asymptotes happen. So if you graph this, guy, seven is whatever, but actually I can do it this way. Okay, minus 4. Just want you to see the picture. So as you can see, at 2, we have an asymptote, and at negative 2, we have another one. So the limit is approaching infinity from the left at negative 2 and from the right. Same thing for 2. So the limit will be infinite for both of them. Okay, so it all depends on what the graph is doing. So when they ask you what's happening from the left at 2, you go to 2 and say, okay, well, I'm shooting off to infinity, so the limit is infinite. Okay. If you're shooting off from the right, it's still infinite. If they are the same, we said by definition, if the limit on the left, limit on the right are exactly the same, then the limit exists. But anyway, is there any questions when you're doing a problem with the graph? They gave us the graph, so there was not much to do. I factored it for you just so you can see why there is asymptotes. Okay. Is there any question as to why there's asymptotes? Or why the limit is infinite? Okay. So number 2 is very similar. If you plug in minus 2, what happens? Do you see? You see that dotted line, the blue one? It's causing division by 0, so the graph can't cross it, so it starts approaching it. That's why it has that weird shape. But from the right, it's going to positive infinity, but the left is shooting downward. So if it's going down, you're going to put negative infinity for your answer. Okay, does that make sense? So check it out right here. From the negative side, the left side, the answer is negative infinity because it just keeps going down. From the right, infinity. Okay. Is there any questions on this? All right. Let's move on to something different where we can maybe calculate something. 3 is the same. What's up? Yeah, yeah. Sorry, I had a monster because I'm falling asleep.
It shows.
Yeah, I'm trying to relax. Oh, yeah. Does the idea make sense to everyone? It's not too bad. I think at the beginning we said does not exist, right? The beginning of chapter 2. So now you're just going to put infinity. On the exam, there's not much to say. You can explain it in words if you want. Like as we approach 2 from the left, this is happening, or from the right, this is happening. That's all you have to say. If you want to graph it, you can, but it's okay. Either way, just gives them a basic explanation. Any questions on 2 or 1? All right, guys, cool. Move on. All right, let's find something different then. 4, same type of deal. So it's 5. It's boring. This question sucks. Someone deleted it. 20 different parts. Okay. So this one's asking you. So let's see if we can solve this one. Why doesn't it exist? Why doesn't it? Find the asymptotes. If any.
We just put there's no way to get 0 in the denominator.
Pretty much. You try to solve for it, you're going to see it, right? So we know that whenever the denominator is equal to 0, we have asymptotes. That's when it happens. Back from college algebra, right? But if you try to solve this, what happens? It's my t, by the way. Can you solve it? Can you square root a negative? Right? There is no real number. There's a complex number, but no real number. So this right here shows us no real solution. Therefore, no asymptote. If you were able to solve it like that other one, we had a x equals 4, or no, x equals 2 and -2, right? That first one. That had 2 solutions and 2 asymptotes. So if they would have asked on that one,
I was wondering about that because you put x plus 4, x minus 4.
I did it in a, should be 2.
So
Should be 2. Yeah, there it is right there. Thank you. So if they were to have asked for number 1, you would have said this bottom part to 0 and solved. Right? But they didn't, so we're good. So these would be vertical asymptote. But anyway, they're not, so who cares? Okay. Is it clear how you find vertical asymptotes? Do you see why there isn't any on 6? All right. Number 7. Is there a vertical asymptote here? Do you remember the restrictions on logarithms from back in college algebra? Well, let's just graph it. What's it?
No, you can't take the log. Zero.
Yeah, that's what the restriction is built around. You can't have 0 in there, so it has to stay above -3. -3 is not allowed. Like if you were to graph it, right? You'll never process there. So we have asymptotes whenever logarithms are equal to, whenever the argument becomes 0. So whatever value makes it 0, that's the asymptote. So right here. So the work you would show, I suppose, for number 7. You write it down real quick. Find the vertical asymptote, if any. So for a logarithm, all you have to do is say the inside must be greater than 0. Solve for x, and you get your, I'm sorry, that's for domain. We just want to know when it's 0. So solve for x. So it cannot be -3. So this is your vertical asymptote.
So we can just do that, set it equal to 0 and find that, or we can graph it and see it.
Yeah, if you graph it, you'll see it for sure. And you can say vertical asymptote happens at x equal to -3. But if you didn't have a graph, you'd have to remember that you cannot have 0 inside ln, and those create asymptotes. Does that make sense? Any other questions on 7? There's a lot of conceptual questions here in this chapter. The next chapter is going to be all about problem solving. So if you hate this, then great. If you like this, then I'm sorry. It's going to change quite a bit in the next chapter. Okay. Alrighty. This one's pretty clear, right? What makes the asymptote? Yeah. But if you see that if you plug in 2 in there, you can get a 0, right? So anytime you have a 0 on the bottom, you will have a vertical asymptote. So that one's guaranteed always. Another one would be the logarithm. Zeros in, if there's a zero in there, you'll always have a vertical asymptote. So all you'd have to do all we would have to do is set the denominator to 0. This is your vertical asymptote. So the E doesn't do anything for you. E is defined everywhere. And it's never equal to 0. So we're safe because technically E is on the bottom, right? You see that negative power? This is equivalent, or actually equal. Equivalent is different. These are equal. So one issue is when is this 0 and when is that 0? But since this is never 0, we don't have to worry about it. Okay, but technically we should be like, oh, wait a minute, there's 2 factors down there. Let's solve for x, but there's no solution. So we only got this guy. Any questions on number 8?
Well, was it the either of it was 4 to like make power and have to bring that down?
Yeah, if it was like x to the -2, then it'd come down, which would then have another asymptote, like x equals 0. That's true.
Because it'd be like x times 6x minus 2.
Yeah, it'd be x times that, right? Mhm. So you have 2 factors that could be 0, so you got to check.
If it was a number, maybe if it was a number up there, like.
Yeah, you don't have to worry about it because the number won't change no matter what x you choose. So you just got to check if there's any x values that will create zeros in the denominator. That's it. Okay, so all these are pretty much the same. So let's go to something else. No, that's it. That's pretty much it for surprisingly 2.5. I was expecting something else, but oh well. Anyway, any questions on any of those things we talked about? Can you find vertical asymptotes? Do you know if it's a positive or negative infinity?
Only one question. But the E -2x equals 0, no solution. What? No solution.
Well, if you try to solve for x, you need to introduce logarithms on both sides, but then you'd have a log of a 0 or ln of 0, which is the problem we talked about earlier. Also, if you graph e to the 2x, it never hits 0. It approaches 0, but never gets there. So if you know what it looks like, then you'll see why there's no solution. If you try to solve it with college algebra techniques, you'll also see there's no solution.
So is it fair if I see the E with some exponent above it with an x, to just assume there's not going to be a solution?
Yeah, let me see. Proving the word always is a big deal, so give me a second. I don't think there is any variable or any factor has a power on e that will make it 0. Yeah,
Okay.
it will always, if you had an e to any power equal to 0, will never have a solution.
Is that only if it's on the bottom?
No matter what. I don't care what power it's up here, never going to be equal to
I
0.
mean, like in the denominator.
It doesn't matter where it's at, but the only reason we cared if it was 0 was because it was in the denominator. We wanted to make sure it wouldn't make the whole thing division by 0.
Like in that case, the one that's on top, the first class is 2, but the one that's on the bottom. Right?
Well, these are the same. The negative power means you can bring it down to the bottom and make it a positive power. But remember, negative exponent rule says you can bring this to the bottom and change the sign. But it was what was this rule? X the negative n will be 1 over x again. Or if it's negative on the bottom, you can bring it up top. Basically, you can move any factor wherever you want, up or down, but the sign will change on the power. That was one of the rule of exponents from way back when. So the same rule here applies. Bring it down. So the reason I cared was I saw that this means it's on the bottom technically. So I was afraid something times something could be 0. Because if one of them is 0, then we have a problem. Or if both are 0, we have a problem. We have to check. So we only ended up having one problem at 2. But yeah, there is no power that will force a 0 on any variable or number. Right? It doesn't matter. But anyway, that's 2.5. Any other questions that vertical asymptotes make sense? You know when they happen, right? Anything that makes a 0 on the bottom is going to create them. And there might be infinite limits at those values, maybe. Or they might be a negative infinite, or it might be positive, might be different on both sides, but most likely it would be going to infinity.
You said anything that creates a 0 on the bottom will make it a vertical asymptote?
Yeah, any x value that zeroes out the denominator is a vertical asymptote.
Like the log.
Yeah, the log is another one. So anything that makes the 0 inside of a log is also a vertical asymptote. Yes.
You said that right now about those 3 different situations on the limits, that we're talking about the conditions.
Yeah, like
We revert back to-
the first few questions, you can have it approaching to infinity, right? Right here. Let me share the screen again.
Oh, never mind, I'm thinking of continuous.
Yeah, that's
That's something different.
yeah, it is different, but I mean, there's some relation there, right? I think there was one in here that mentioned it. Removable discontinuity. Didn't really talk about it much here, but I think it was the last section, right? Okay. give you some theory. Then, let's see. Let's see, I guess. You guys have any questions before I start a new section?
Yes, I do.
This is 3.1 yet. I'm gonna save the review for next time. So if you want to do some homework, what do you got?
2.4. Here's gonna just be Iowa carded.
2.4, let's see.
Number 7.
Homework 2.5, is there a fast way to go straight to 2.4?
If you just go to the homework, you don't have to.
Yeah, you can-
Is there a button that can just go straight to
My
2.4?
assignments.
Yeah, you should be able to click, I mean, if you click any assignment, can't you just go to something else on the list or not? You said 2.4, right?
Yes.
7? Okay. Find the x value that at which f is not continuous. Is discontinuity removed? It's only removable if something cancels, right? Do you remember? If you factor and something cancels, that is removable. There's nothing to factor or do here. So for sure, it's going to be non-removable because of that. Then the value we can plug in that causes that asymptote, right? Now that we know that what that is again, that's going to be the point where it's not continuous. Remember the definition or the 3 requirements for continuity, right? There was the function has to exist there, and you can't plug it in. You cannot plug in 0. So that's why it's not continuous. But the limit exists, right? We showed that we can approach there, but not continuous. Does that help? Does that make sense? What's bugging you about number 7?
7 over 0. Yeah, I guess that would be wrong.
Yeah, you can't plug it in. You cannot divide by 0. Same.
Trying to get up on 2.3 for 5.
2, 3, 5.
Dates on it. Dates.
Yeah, I finally put due dates for you. Popular demand.
What's that here?
2.3.
Sorry. 2, 3, 5. Okay, so this guy can be factored, right? Something's going to cancel. See it? Number 5, 2.3. Let me write it down. the first thing you should do, yeah, maximize this, is factor the top. We get x plus 3, x minus 3 using the difference of squares, right? So that's going to cancel this guy. So because it cancels, we have removable discontinuity at x equals to -3. Because -3 is the one that would cause division by 0, right? So that's this is where we had problems, but we removed it by the cancellation. When we factor. That's how I remember it. Something cancels, that's going to be the point of discontinuity. Removable, sorry.
So does limit and discontinuity really mean the same thing?
No, the limit is required to show continuity. Right, remember there was 3 requirements for a function, right? To be continuous at a point. It said the limit has to exist at that point. The function has to be the same. Well, it has to exist also, but it needs to be the same as the limit. And I forgot what the third one was, but they're all similar. But as soon as you see that the limit does not exist or it's infinite, then you would say not continuous. Because at the asymptotes, right, there's no actual value, and you can't plug it in. So right away, not continuous. Okay. But see here, the limit existed. We couldn't plug it in until it canceled. So now it's removable, which means we could plug it in here. But that one's different.
How would you get 6 here?
Oh, once you remember, taking a limit means you just plug in the value, right?
Okay.
But we don't plug it in unless we're able to. At the beginning, we were not able to. So we factored. We got left with this. So you can.
The simpler function would be the one that doesn't cancel out, right?
What's that?
The simpler function would be the one that doesn't cancel out, right?
Yeah, this leftover part right here. Yeah, this is the simplified version or the simpler function, right? You're right. Didn't ask for a limit, but
Oh, yeah, it was wrong
Oh, yeah.
size X, that's fine.
what happened?
It was the wrong size X.
Oh, you had a capital or something?
Yeah. I had the top one switched up. I was getting mixed up, but
That's frustrating. I've had that happen. I've done that with T's, like capital T or lowercase t. And the worst one are L's. Sometimes I can't tell the difference between L and capital I or something. So I just get really frustrated. But anyway, it happens. Any other questions?
2.2, number 12.
2-2-12. 2-2-12. All right. Okay, let's see. Consider the following. Sketch the graph. Okay. Identify values of C for which the following limit exists. Find the limit of all points on the graph except where C is equal to 2. Oh, okay. So first, once you pick the right graph, you basically want to find points that you know are going to fail the limit definition. Remember how they have to be the same on both sides, right? You should see at 4, they're not the same, right? We're going to 0 over here. The limit on the left is when x approaches 4 is 0. But from the right, it is equal to 3, it looks like, right? So this limit does not exist because they're not the same. Everywhere else, limit exists. There's no other issues like that have a gap like that, or they're different, or going to infinity. So there is no other location that has problems. So right away, I would say, well, the limit approaching 2 does exist. So I don't know what the hell you're talking about. A is wrong. B is just saying almost the same thing. C has the only point that we mentioned right now. The limit exists everywhere except at 4. So you would choose this guy, C. Do you see why I eliminated A and B? Right, because we're good at 2, right? This is going to the same place. D is wrong because we just said there's an issue somewhere. To just start eliminating the ones that make no sense. Once you eliminate 2, A and B had to be removed. Yes.
Why would it be the graph on the bottom?
This one?
Yeah. There's a hole on that.
Hole here, that's
Oh,
this
I changed
line.
that one.
What's up?
It's, because it's a greater than or equal symbol. Yeah, so it can equal 4.
Yeah, that's true. The line has to be filled here.
Greater than or equal means that the circle has to be solid.
And on this guy, you have less than, so it's a hole here. Yeah. When you're doing these piecewise, I mean, if you don't want to do it by hand, I would just eliminate the ones that make no sense. Like check the holes, check if the line is going in the right direction. Like right away, you should see that B makes no sense because it should be going past 4, not below -4. You see that? The constant horizontal lines are constant functions. So at 3, it should only be equal to 3 at beyond 4. So it's either going to be D or A. The rest make no sense. And then you eliminate the rest by checking the holes.
On the test, they don't have the graphs for us to choose. It's a good question like this.
I think so. I think you'll have some graphs. Some you might not have any graph.
I mean, if we're given piecewise functions like this, we get the graph, or we can have to like graph ourselves. in the calculator.
I don't think you have any piecewise. But we'll talk about that during the review, like which ones to look out for. I need to check, and I'll let you know. But I don't remember a piecewise. I don't want to promise that till I look at it. So, any other ones? Questions?
That's from 2.1.
Sure.
It was 2.1. 5.
5. Use the rectangles in each graph to approximate. Okay. So basically you're finding the area of each rectangle, just doing length times base times width. That's all you're doing. But I'm sorry, base times height. But the height is determined by this function here. See what I mean? So you plug in the number 1 and you get a height of 5. Plug in the number 2, you get a height of 5/2. So that's where all these rectangle heights are coming from. So you multiply the width is all 1 times that specific height, and you just add up the rectangles. So when you add them up, you're going to get some stupid number. But basically,
That one confused me, like, too bad. I still got the right answer, but I was confused the whole time.
There was a video on this that actually gave the right answer.
Yeah.
yeah, let me see if I have a nice picture on here. Here, this is what I'm trying to say. When x is, so the formula is 5/x. That's creating the height, right? You start at 1. So 5 divided by 1 is 5. 5 divided by 2 is 5/2. 5 divided by 3, etc. All the way up until 4. Sure. So you just add up these fractions and you'll get this area. So on your calculator, you just do 5/1 plus 5/2 plus 5/3 until you get to the last triangle or rectangle. Sorry.
So just like 5 plus. Say -1.
Pretty much. Yeah, so 1, 2, 3, 4. Let's see what they say. Next one. But anyway, it's like they're making it more complicated than it needs to be. You're just like back in elementary school, right? Base times height plus base times height. You're just adding little rectangles. That's all we're doing. It's just that finding the height uses a function.
This is gonna be on the test.
No.
Oh, okay.
No, I don't like that question.
It's real weird, sir.
Yeah, it's used for something at the end of this class, but I don't worry about it.
Why are they giving us that X, the other stuff on the Y equals 0? X equals 1?
Video notes weren't like real good.
Basically, they're telling you that this here, so I can write on it. What they're saying, where's my pencil at? X equal to 1. X equal to 1 is this line here, straight up. X equal to 5 is this line here. So they're asking you, what is the area underneath the curve bounded between 1 and 5? That's what this is trying to say here. This curve right there is the black line. So the black line is bounding the area.
Oh, yeah. When it says Y equals 0, it's showing the bottom x-axis.
Yeah, exactly. So we're bounding it below, on the sides, on the top. We want to know what is that area right there. So if we keep making the rectangle small, creating more and more rectangles, if the rectangles go to infinity, then we'll have a perfect amount of area. That's the theory, which will come up like in at the end of chapter 5. It's the last section of the whole class. So I don't know why it's here in this section. But anyway, so all you're doing is adding this area plus this area plus this area. That's where this came from here. These rectangles are smaller, so there's more of them. Okay, so that's why they're not as pretty as these. Because notice how the width, the base is no longer a single one, right? So now that's what, a half? Yeah. So each base is a half. That's why they have the 1/2 out here. And they have more of them. So these numbers will come up from here. Plugging in, changing that X value. So at 1, 1.5, 2, 2.5, because the rectangles are skinnier. You have 2 for every 1. Okay, but anyway, I wouldn't worry about that question. Ooh, excuse me.
Let's make a lot more sense. Sometimes video notes suck.
Yeah, I guess so. I guess we'll stop here unless you guys have some questions. Any more you want to work on? Any other issues you're having? Still want to save the review for Wednesday. And then the week after that, we'll start chapter 3. And you can take the exam anytime you want. Okay.
So we're not doing 3.1 right now?
No, we're gonna hold off.
But there's one thing I wanted to ask you.
Sure.
If I can find it real quick. I could not get this answer right for the life of me. I got everything else right. I got like a 97.3, but there's one question.
We're at
All right, it's a 2.2 question 3. I got the table right. I got all that right. The only thing I can't get is 0.
question 3.
Yeah, 2.2 question 3. I got the whole table right. The thing I messed up is the part B. You use the result to estimate the limit. I could not.
Okay. Estimate the limit.
Yeah.
Well, remember, what does limit mean, right? What is it approaching on both sides? It should be the exact same number.
I tried everything.
But what did you have here?
So that's not the same question that I had for the exact question 2.
Oh, that's 2.
2.2
Sorry.
question 3.
Okay. So what did you have on the sides? Right close to, right next to 0.
Right next to it,
Mhm.
0.0020.
And then the other side?
Same thing except negative.
So the question becomes what's in the between them?
Nothing but 0.
Yeah.
I tried putting that in. It didn't work out.
Yeah, it should be 0. It's,
Is it 4 decimal places?
And it's 5 for this question, right? Like, oh no, it is 4. Okay.
yeah, so it'd be 0 point and then 4 zeros.
I'll try that.
Yeah, it must have been weird about the sig figs or something.
Yeah, I was trying all kinds of things. I was like, does it exist? Okay, no.
But I mean, you're right. So I don't know why it's being weird.
Alright. Thank you, sir. That's
Yeah.
all I had. Are we
Okay.
good then?
Yeah, you're good.
Okay.
You guys want to stay and ask questions? You can.
Go over the dates again. Homework is due by.
Yeah, let's look at that. So I put dates on.
Don't change the due dates. I like the due
Please
dates.
don't.
Don't change the due dates.
Chapter 2 is due 14th.
Okay.
2-1 through 2-4
Dude,
will close on Valentine's Day. I haven't chosen any dates for 2-5 yet. So try to finish them. No pressure.
I still did more than I did last semester at this point.
No, yeah, you're doing good. I'm happy that you have lots of questions. That means you're working.
Have your, something?
Sure.
For 2.3, question number 6. I just want to make sure I'm doing it right. Pretty sure I am, but could very well not.
Number 6. This guy.
2.3.
Is this it?
Yeah, question 6.
So did you use the difference of cubes formula on top?
Nope, because I'm trash.
Okay.
Sorry.
Sorry, I'm trash too. I don't remember the difference of cubes. There it is. Difference of cubes. I don't use it very often. Maybe like 5 times a year, maybe.
I'm just doing a bunch of other things, but not that.
It's all good. Okay. What were your numbers?
Times a limit as x approaches 2.
The limit as x approaches 2.
And then is x cubed minus 8 over x minus 2.
Okay. So use the difference of cubes on top. So that is the same as x cubed minus 2 cubed, right? Which will then be x minus 2 times x squared plus 2x. I don't have space. I'm gonna do it over here. Start over. X minus 2 times x squared plus 2x plus 4. Sorry about that. Okay, so rewrite it in cube form so you know for sure what is a and b. So there's a cubed, b cubed. So that goes here and here. And let's erase this nonsense. So these will cancel, creating a removable limit, right? So we have something. So let's plug it in. We now are able to. So plug in 2. What do we got? Some number that nobody cares about.
It's not. Seriously, that
It's 4, 4, 4, 4. So the limit is 12. Once you remove it.
yeah, I was super lost in the sauce. Yeah, that's all I have.
14, this Wednesday will be.
The
doing
first four
review.
sections. Well, we started today. I haven't put a due date yet. 2-5. 2-1 through 2-4 is due on Valentine's Day. That's my gift to you guys.
It's 2-9, we're just gonna do a review.
Did you say 2-3, Mr.?
Valentine's Day. It's plenty of time, assuming you started a long time ago. And we still have over a week, or about a week, exactly a week.
My chemistry teacher doesn't understand what kind of homework load they're giving right now.
Yeah.
This man, he gave us a whole section of homework devoted to Excel training videos. That's what I said,
I mean, it's cool, it's making you learn Excel, but I mean,
an entire section of homework due to just Excel, watching Excel videos. And you have to watch them to completion to get full credit. So each Excel assignment takes like an hour. Yeah, and I'm like,
especially if you already know Excel. Like,
but I want that credit.
but yeah, you have to.
So 2-9, we'll be doing the review and then touching on 3.1.
Yeah, Wednesday we'll do a review and maybe 3-1. But for sure review, but I might say 3-1 for Monday.
And you said the test is gonna open right after that on the 10th.
Yeah, I'm trying to open it as soon as possible, but probably by Wednesday I'll open it up.
This Wednesday coming up?
Yeah.
2-5 gonna be on it?
Yes. All of chapter 2. Right, that's why I wanted to review first, because 3-1's not on there, I don't think.
So we'll be reviewing 2.5. and then
We'll review the entire review together. If there's some 3-1 on there, we'll talk about 3-1, I forget. I need to check.
That's why you know how much we appreciate you.
Thanks. Appreciate it. Thanks for saying that.